Hello, hello, hello. I've got a really cool proof of the tangent half angle identity, and I wanted to show it with you. I've never seen it before. It's really pretty cool. So let's say we have a semicircle of radius 1. Okay. So from the center point to this point is 1. And let's put a triangle inside of this semicircle here. And let's call this angle here theta. Then, since this is a central angle, by those circle theorems, this angle here is theta over 2. And this length of the hypotenuse is also 1 since it's a radius. And if this is inscribed in a unit semicircle, that means that this length here is cosine of theta, and that this length here is sine of theta. And it also means that whenever you have a point of tangency to the when you got a triangle that's tangent to a circle, and you draw that tangent line, the angle see, if I draw this line here, that means that this angle is a right angle, is what I'm claiming. And you can tell it's right because of that point of tangency. When we've created a full triangle here now. This is one full triangle here. So that angle is right, is the point I am trying to make. All right? So that length there is sine theta. Now I drew this other line here. So I think I need to grab this and make it bigger. Let's make it bigger. Okay, so now what I'm going to do is, this angle, the right angle, is right. So, and this is a right angle because it's a right triangle. So what does that tell me? It tells me that this angle right in here, hopefully you can see where I'm drawing. I'll put it in blue so it stands out more. That angle there, that angle is theta over 2 as well. And since it's just by the circle theorem, since it's not in the center of the circle, it's an angle that is, it's not an angle that's in the center of the circle, it's a angle coming from the circumference of the semicircle. And since this whole length is 1, then the length here is going to be 1 minus cosine of theta. And I've done all the geometric setup now. So that means if I were to take the tangent of theta over 2 of this blue angle here, that is going to be the opposite over the adjacent. In other words, 1 minus cosine theta over the adjacent, which is sine theta, that length. Or I could do the other angle of theta over 2. So that gives me sorry, I had a brain fart. So 1 minus cosine theta over sine theta, so it's the opposite here, over this adjacent length, opposite over adjacent. And I could do it with this angle here, so that's the opposite length, sine theta, over this whole length, which is 1 plus cosine theta. So sine theta over 1 plus cosine theta. And that is the